Okay, so we're going to look at transformation of the exponential functions, and this is from like the original first chapter where we looked at transformations. When we look at transformation of exponential functions, there's two things that we want to keep track of. We want to keep track of that reference point at 0, 1, and we also want to keep track of our horizontal asymptote at y equals 0. Okay, so those things allow us to keep track of our transformations. So if I were to take a look at this graph here, I've got my vertical transformation. Okay, I'm going to do that vertical transformation in my change in y. And my change in y is going to be the outside transformation. So it's going to be, first of all, vertical expansion by 3. That's my first step. My second step is a vertical shift minus 4. Okay, and again, with vertical, we don't have to worry about doing opposites or anything like that. With my x's, I'm going to do the opposite. Okay, there's only one transformation here. It looks like the exponent went from x to x plus 1, so my change in x is just one transformation. I'm not going to undo it. I'm just going to say that my horizontal, we have a horizontal shift minus 1. Okay, so what happens to my coordinates? Okay, so I have my table of values, my old x's. Okay, so xy, my old x looks like that. My new x, y, so that's my old, new. I've got a horizontal shift left 1, so it's going to be minus 1. My vertical, I'm going to have a vertical expansion of 3, so it's times 3, then minus 4. I'm going to end up at negative 1. So there's my reference point. Oops, negative 1, negative 1. There's my reference point. Now my graph is going to look like this, but I want to keep track of my horizontal asymptote. So the horizontal asymptote, if I expand it by 3, nothing's going to happen. And again, the horizontal asymptote is actually a y line, so we have to do a y transformation to it. So expand it by 3, yeah, nothing happens. It's on 0, so it doesn't expand vertically. And then I'm going to shift it down 4. So I'm going to go 1, 2, 3, 4 down. There's my new asymptote. So I can draw my function. It just follows the asymptote, goes through that point, and that's all I really need for my transformation. Okay, so there's my transformation. So we're really actually interested in the inverse. What happens when we undo an exponent? Okay, what does that look like? Okay, so what is an inverse of an exponent? Well, this is what we're actually getting into. We want to be able to undo an exponent. And we use something called a log to do this. Okay, so the log is a logarithm. Log is the inverse of exponents. Okay, so if the log is an inverse of an exponent, what does a log look like? Well, we can use a property of inverse. So there's my x, y axis, and we know that inverses are reflection across this line y equals x. So if my original graph, exponential graph, looks like this, okay, and we have a horizontal asymptote at 0 and a point at 0, 1, well, the inverse must be, so this is, let's call this y equals a to the power x. Well, the inverse must have inverse properties. So if the point is at 0, 1, we must have a point at 1, 0. We just switched x and y. If there's a horizontal asymptote at y equals 0, there must be a vertical asymptote at x equals 0. And it should be a reflection across that line. Okay, we should have a mirror image. And so this would be the inverse when we switch the x and y. Okay, there's our inverse function. And this is what a logarithm looks like. Okay, this is a log graph. This is the inverse of exponents. So this is what we're going to start getting into. We want to be able to undo an exponent.